Hey everyone, Dr. Keith here again. So let's keep going in our module on databases. You've learned a bit about the purpose behind databases and how relational database management systems help in avoiding data redundancy and giving us quick access to data. You learned how to begin diagramming databases conceptually using ERDs, which is a sort of shared language or a way to share requirements between the business side and IT side. You've learned how to then implement those ERDs in Access and create those actual entity relationships which enable data to be tied together. But now you're going to see the real power in tying that data together in those relationships in Access as we generate and create Access queries. So look through this chapter, understand these key terms. An Access query gives us a chance to use the physical view of the database. The physical view refers to the actual tables that exist, and then we create as many logical views as we want. So a query is another term for a logical view or vice versa. So you're going to learn the basic skills of querying. Why? And why would you do this in a class where you may not necessarily be an IS major or something like that? The reason is because database skills, specifically querying data, is becoming one of the hottest topics for all business school majors. So part of why I included this is I go to my own students' career fair. They have two of them a semester. And I go to the career fairs and I talk with each of the recruiters of all the big companies, and I ask them what some of the most current and necessary skills are for all of these different majors, for finance, for accounting, and querying databases repeatedly comes up. Why is it so important? Because if you can't do this, or if you don't know how, then you're going to always have to wait on the database manager or the IS department to give you the results or the data that you need, because you're going to be solving business problems, which is going to require getting your business's data and performing some type of analysis. If you don't know how to query it, then someone else has to do it for you, and then you're going to be waiting around. You're less useful. You cost the company more money. Whereas if you can do this themselves, then it's a lot easier for you to just be integrated right into the team. So they want everyone to learn queries, and you're going to learn them here. And it's not as difficult as it sounds. You're going to learn them in two ways. First, we're going to learn how to do queries from what's called design view. Now, you might be worried, well, hey, why are we learning how to do this in Access? Because every program's different. Or because my company won't be using Access as their main database management system. That's absolutely true. However, I've used almost every one of the big corporate database management systems, and their query design views are all very similar and based on the same principles. They're different, but they're not so different that if you learn how to do this here, you couldn't then go and apply it into another system. So let's learn it in Access, and then the next chapter, you're going to learn the underlying structured query language. So Access and Design View actually just writes SQL behind the scenes. Every database management system, well, all the big ones, all use SQL as their language that actually executes the queries. Not a tough language to learn, and I'm going to teach you just the basics of that in the next chapter. But for now, let's make queries in Design View. So scroll down here. Well, watch my Karate Kid video if you want to. This is you guys. You guys are Karate Kid. Your instructor's Mr. Miyagi. You've been going through all this work learning how to do ERDs, and it's been tough. I know it's been tough because I remember learning it. But you're about to see it all come together now in queries. Anyway, watch that scene. It's a classic. Scroll down here then, and here's our query exercises. So if you did the Gold Star case from Chapter 1 here, you may remember this data. Go ahead and download it. It's an Access database. We're going to use this for our examples. And then we're going to answer each of these queries right here. Okay, this says this type of file can harm your computer. Yes, it just means that databases can have extra code written in them that could do terrible things to your computer. Absolutely true. But you can trust this. Go ahead and download it, open it up. I'm going to resize it here to fit in this window. Okay, enable content. It's our security warning that says it's okay for it to run code behind the scenes. Promise I'm not scanning your computer for personal information. Anyway, here's what we have. 3 tables. here's a query that's been created. We're going to ignore that, but examples of some forms and reports. Feel free to just explore these. These are cool. Here's a report of data that's in the system, but it's a nicer way to view the data other than looking directly at the tables. Here's a summary of all the positions in our company and who we have in each position. There are those with various performance ratings. See how it's summarizing things for us? This report comes from the employee table, which is right here. So if you haven't seen this data, take a look and explore it. It's always the first step to queries. Find out about your data and what it is. We have an employee table here. These are the people who work for us, their hire dates, their salaries, performance rating must have been given by a manager at some point. And then we have a couple of foreign keys here, position ID and location ID, which take us to the location where they work. And notice this plus sign here, that means that we must have created these relationships already, like we learned in the last chapter. I can click on this and I can see all of my employees who work at Boston, all of my employees who work in Atlanta, so forth. And then here's my position table. These are the various positions in my company. I can also look and see who are all my managers, who are my account representatives, so forth, trainees, all that stuff. So that's my data. I'm going to close those out. No. I'm going to close out my report too. Yeah, it's easier. No, I think I like it the other way better. Actually, yeah. I'll just click on this. Then I can pin it. Close print preview. There we go. And then here's some, that was my report. Here's some forms. A form is just supposed to be an easier way to enter new data in. I don't know that this one's really all that useful. Location's kind of a nice form. Another way of entering people in for a specific city. Anyway, so let's begin by going through each of these queries. So these are all examples of questions or data that you might need for some business problem. Or maybe it's your manager who she or he has not learned how to do queries and they've hired you as a new intern and she or he wants you to run a bunch of reports, or in other words, query some data and give it to them to help them make a decision. So let's assume that for each of these queries, whoever it is that's asking this knows what it is they want. Some of them seem ridiculous, but we're going to assume they've got a reason for why they're asking for them. Our job is to simply execute the query and make it work. So, first one, from the employee table, select all fields or all columns for all employees, but then sort them in ascending order by last name. Okay, come back here, create a new query, and let's use query design. Don't ever use query wizard. It's an artifact of access that nobody uses anyway. So it says here, which tables do you need to do this? Well, back here on our question, it just says from the employee table, select all fields. So I don't think we need anything from location or position. Just double click or hit add. Close this out. All right, so what we have down here is sort of a blank space to put fields in that we want to select. So we can do this two ways. I can start double clicking on each of these fields and it'll say, okay, we'll grab all of these things, salary, gender, performance, position ID, location ID. And it says, okay, here's the field name, here's a table each of them are coming from, show it. You might wonder, well, duh, of course we want to show it, but you'll see why we need this later. If I come here and just hit run, it gives me everything that I just had in that table. Go ahead and hit save, and let's call this, just like it is, it's query 1, it's answering question 1, and it puts it right here, query 1. Now my question for you is, did we just increase the size of the database by this amount? No, we didn't. That's because a query is simply a logical view of the database. The physical view refers to each of these tables. This is where the data is stored. That's what's taking up most of the space. The query is executed when you run the query, meaning it copies and pulls this data right here into RAM when you execute the query. What actually gets saved when you create a query? Well, come up here, click the down arrow, and go to SQL view. This little bit of code, select employee.social security number, last name, first name, all these different things. Select that from employee. This is called structured query language. We're going to learn this in the next chapter. Don't worry about it for now, but this is all that gets saved for query 1. Even if there's a million records, those million records get pulled or copied when query 1 is executed. We haven't actually increased the size of the database other than the teeny little bit required to store this text. So that's why we say have one physical view and as many logical views as you feel like. So another way to run this, if we're back in design view, we don't have to hit run. If we just simply change it to datasheet view, it's going to execute it as well. Anyway, we're not done. It said grab all these fields and then sort it by last name. So let's find last name. You'll notice there's this, here's last name. There's this sort option here. If I click on this, it says ascending or descending. They didn't tell us which one to do, so typically we'll assume ascending. Now let's run it. There we go. Now it's sorted by last name. Now again, you might ask, well, duh, why didn't we just open the employee table and hit sort by last name like this? Well, that's useful for now, but maybe we want the permanent sort by last name for some other reason. Who knows? Again, we can save it that way as query 1. Let's close this back out. Nope, don't save it. Okay, so you might have noticed there's also a hint here. You can show all fields for a particular table by including the star field in design view. So if we come back here to design view, hover your cursor very carefully over this part of each field and hit delete. Again, hover until the cursor turns into that downward facing black arrow. And I can even click and drag and I can delete all of them. So if you ever put something in you don't want, do that to delete it. And what it's trying to tell you is that if you use this star right here, it's going to automatically grab every field. Run. There it is. Problem is, we haven't permanently sorted it by last name. Well, if I come here and try to hit sort, it doesn't quite know what to sort on. Well, we're selecting everything. Which one are you trying to sort it on? It'll probably sort it based on whatever the first one is that shows up on the list. So that's not going to help us. What we're going to do instead is grab last name a second time, even though I know it's already included here. But uncheck show. We don't want to show last name twice. We simply want to use last name to sort ascending. So if I run that, here it is. Everything's sorted ascending by last name. Now if I had not checked this, watch and see what it does. Hit run. And it simply grabs, and it calls it field 0 because it says we already see something called last name. Actually, there we go. And there we go. Employee last name. And it called it field 0 and it's sorted by that. So we just deselect it to do what we want. So save this, close it out. We're done with query 1. All right, on to query 2. Let's create query design. Let's see what it says. From the employee table, select only the first and last names and salary of all employees. Okay, what I want you to do is focus on returning things in the order they're requested here, and never return more than is requested. Okay, employee table, that's all we need. Close this out. Return only the first and last names and salary, not a problem. So now I'm just going to say first name, last name, salary, in that order. Did it say anything about sorting? Nope. So don't sort, just run. That's all it is. Save query 2. Okay, now we're cooking. Number 3, select employees who received a poor performance rating, and only those who received a poor performance rating. In the results, show only the first and last names of the employees. So we don't even want to see their performance rating. All we want is first and last names for only those who received a poor performance rating. All right, let's do that one. Create, query design. Everything we need is still in the employee table, so just select that one. So it says only show, what's the order? First and last, okay. First name, last name. And if we want only those who received a poor performance rating, we still need to get performance, but what we're going to do now is use what's called criteria. All right, before we do this, let's take a look at the actual table and see what the data looks like. So here's the employee table, the physical view, and we see performance rating right here. All right, it looks like it comes with these words, average, good, poor. I don't see any very poors. We want only those who are poor. Okay, we can do this. Close it. Here's what we do. Down here, we just write the word poor. And notice as soon as I leave that, it's going to add double quotes around the word poor. So in databases, and you'll notice the same thing when we work with Excel functions or VBA later in the semester, if you do those things. Whenever we work with text, when it comes to code, whenever we want to use text as a criteria or as a comparison or whatever it is, we have to put double quotes around it. That's not true with numbers. Numbers don't use quotes. Text uses quotes. All right, so give me all employees whose performance rating is poor. So I'm going to come up here. If I right now I'm not seeing my query exclamation point. That's because I'm on the Home tab. I can click on Design, then I get it, or I was there, I could just switch back to Datasheet view and it'll still run it. All right, here's my 3 people who were poor. Notice it said only show first and last name though, and not performance. I like to leave this initially just to check and make sure that it didn't give me anyone who wasn't poor. But now I can go back here and deselect performance and say, still use this as a criteria, just don't show it to me in the results. Run, and there we go. Query 3 is done. All right, moving along. Query 4, show first name, last name of employees who received a good performance rating and earned more than 50,000. Okay, see right now if you can pause the video and do this one on your own. In fact, from here on out, every time we go to a new problem, pause it and do as much of it as you can on your own before I keep going, and you'll learn a lot more that way. Anything you can figure out that way will stick in your brain to the degree of about 10 times more reliably than if you simply watch me do it. All right, so let's do this one. It says fill out the query design grid. Hint, be sure to enter field names, table names, and criteria. Not much of a hint, that's kind of obvious. Anyway, let's do that one. Create, query design, employee. Now we have to make sure, okay, earn more than 50,000. Is salary in this table? Yes, it is. So we still don't need location or position here. But let's put in this data. First name, last name. Got it. Of employees who received good and earned more than 50,000. Notice it doesn't tell us to show either of those things. Just use them as criteria. All right, not a problem. We need salary and we need performance rating. I'm going to leave them showing just for now, just to make sure I get it right. So performance should be pretty easy because you saw we did it in the last one. We're just going to put in the word good. Salary is different, 50,000. What do we put here? Well, it assumed when we put the word good here that we were looking for employees whose performance, this field, equals the word good. With numbers, we can use common operators. In this case, we want anyone whose salary is greater than 50,000. All we need to do is stick that operator in right there. All right, let's run that one. Here we go. Each of these people, good performance rating, they're all over 50,000. Everything appears to work well. Anything we're missing? I don't think so. I think all that's left is to deselect show on both of those things. It didn't say to sort it, right? Nope. Okay, that's it. Run. There we go. Save it. Query 4. Close. We're good. All right, 5. From the employee table, select Social Security number, first, last names, and performance rating of all employees who work at location 1. Okay, this is a part that gets somewhat trickier. It's not tricky yet, but let me show you what I mean. In the employee table, open up the physical view. It says location, which they really mean is location ID. Location equals 1. Okay, that's in this table. We don't need to go to the location table yet. We know that location 1 is here, but there's no need to query against this table because it's stored over here in the employee table. So we still only need the employee table. Sure, save it. So create, query design, employee, close. All right, let's make sure we get it all right here. SSN first, first and last names, first, last. And, okay, this is important, and performance rating of all employees who work at location 1. Okay, so we actually want performance rating of the employees who work at 1. It doesn't say to include it, just of those who work at 1. So we will need location ID. Okay, so performance rating, it didn't have a criteria on that one though. Nope, the only criteria is location 1. All right, that's it. Deselect show, hit run. Okay, I think that one's just fine. Save that one and close. Okay, query 5, there we go. 6, okay, here's where it starts to get tricky. Pause it, see if you can do this one. Now let's continue. All right, so we need employees who have either Emily or Frank as their first name. Show first and last name of these employees as well as their salary. Okay, not a problem. Create, query design. We still just need employee. Close. We want to show first and last names and salary. First, last, salary. But here's the tricky part. We want anyone who has either Emily or Frank as their first name. So let's come here to first name. Criteria, we can put in Emily. Well, how do we handle Frank? There's multiple ways. One clue is this keyword right here, or. We can just type in the word Frank down here. And or is different than having things on the same line. Anything on the same line, if you remember query 4, was it? Here we had 2 criteria. Their performance had to be good and their salary had to be above 50,000. On this one, I put them both in the same line, and that implies an and condition, meaning both of these criteria must be met. Notice if I put this one down here on the or line, whoops, what's going to happen now if I run this is it's going to give me more people. Let me go back, check both of these, because now I'm looking at people who are either above 50,000 or good. So here's someone who's below 50,000 and good, and someone who's above 50,000 but not listed as good. So whenever I use more, it's going to expand my results, assuming I've got more data that meets just one of those 2 criteria instead of both of the 2 criteria. Whenever I put them on the same line, it implies an and I'm going to get fewer results. Fewer records back because they have to meet both criteria. All right, close this one out. Sure, save it. Here we have Emily or Frank. So if I wanted to do, well, let's start with this one and run. There we go, Emily, Emily, Frank. What if I tried to put another first name here and add Frank to this first name? Now I'm saying their first name has to be Emily and Frank. What's going to happen? Well, I'm going to get 0 results because nobody is named Emily and Frank. All right. Another way I can do Emily or Frank is I can actually type it right here and say or Frank. Run. It works the exact same way. It has to do with how it's exactly writing the SQL behind the scenes. It's using this where clause where it says now employee first name equals Emily or employee first name equals Frank. And it writes that code exactly the same way whether I put it like this or down here like that. Run, SQL view, it's exactly the same way. All right, so let's save that one. Yep, save query 6. Let's take a look at the next one. All right, 7. Show employees with the first name of Holly and received a good performance rating, but in the same query, select all employees who received an average performance rating. Okay, this is where it gets tricky. Looks like we want people who are Holly and good or anyone who's average. Does that mean we should get a Holly who's average? Technically, yes, right? Because if it says, but in the same query, also add any employees who received an average, we could get a Holly who's average then. Could we get a good employee who's not named Holly? Actually, no. Because anyone who's good is going to have to be named Holly because it's Holly and good. But everybody else we get is going to have to be average. So we're not going to get anyone who's good and not named Holly. I know it's complicated, but it's really important to think through exactly what they're asking for. Okay, go ahead and see if you can make that query. Pause it. Start it up again. I'm going to do it now. Okay, display social security number, first and last names and results. Create, query design, add close, social security number, first, last name. Okay, criteria. We want Holly. Oh, I need performance rating. And we want good. Or anyone who's average. So again, when I put them on the same line, there's an and implied between them. They've got to be named Holly and they've got to be good. Or add anyone else who, it doesn't matter what their first name is, anyone else who simply has an average performance rating. That's how you interpret that. So run it. Here we go. I've got all these averages not named Holly. I do have a Holly Holmes who is average, and I have a Holly Jones who's good. So this is exactly what we were looking for. Anyone who's average, which means they could be named Holly, and only Hollies who are good. Or then people who are good, but only if they're named Holly. That's a better way to say it. All right. Save that one. Close it. Moving right along. 8. Create a query that shows only last and first name, city, location, city, and position title of employees who earn less than $50,000. Okay, not a problem. Create, query design. Let's start with employee. And it says, okay, show first name, last name, and performance rating. Not a problem. Performance rating of from the employee table and location from the location table. Oh no, sorry, I'm on 8. First name, last name, location, city, and position title. Okay, I apologize. Let me delete that. Forgot that I'm on 8. Last name, first name. In fact, I got them out of order. So let's switch this, move it over here. Last name, first name, location, city, and position title of employees who earn less than $50,000. Well, so we need salary in there, and we can put the criteria, less than $50,000. But where do I get location, city, and position title? Because all I have here are the ID numbers. So now this is where I have to pull in my other tables. I'm going to organize these a bit. There we go. So notice it brings in these same relationships that we put in when we used the Database Tools Relationships window in a previous video. If we create these relationships here, then anytime we create a query, it'll automatically bring them in right here. The nice thing about that is now all we have to do is add position title, add location, city. And it's going to automatically look them up for us because those relationships have been created. Cool. So here's where we're getting to what's called a join. A query is powerful because it can join tables together and produce results based on many tables at once. So let's take a look at the data. Here we get last name, first name, salary, position, title, location, city, even though this data came from all 3 tables. Double check. Yep, salary is below 50,000. I think I'm not supposed to show 50,000. Yeah, show only last name, first name, location, city, position, title, who earn less than 50,000. So deselect that, run it. That's it. Save query 8. All right, query 9. Moving along here. Select all of the employees that received, should say who received. Anyway, either an average or performance rating and work in Chicago. So it sounds to me like whether they're average or poor, in either case, they have to be working in Chicago. Show first name, last name, performance rating, and location. It says location from the location table. You might ask, well, do they want the ID or the city? Think about it logically. If you're the manager asking for this, does she or he want to see a location ID? No. If they didn't tell you specifically, you can probably infer they probably wanted to see the city. So looks like we're going to need, do I need the position table? I don't think so. Let's go ahead and make a new query here. Design, employee, and location. Close. So we want to show average or poor. Oh no, sorry, excuse me. Show first name, last name, and performance rating. First name, last name, performance. And show location from the location table. Not a problem. There's location, city. So we've got everything that we need to show. The criteria is they had to receive average or poor and work in Chicago. So a couple ways we can do this. In performance, they can be average or poor. And then location, city, we can put Chicago there. But we'd also have to put Chicago here. Now you might be asking, does capitalization matter? It depends on the database management system, on the specific version of SQL they're using. In this case, no, it doesn't matter. But others it might. So let's just develop good habits, I guess. All right, so this will work because it says average and Chicago or poor and Chicago. Let's double check. There we go. Average Chicago, poor Chicago, average Chicago. Another way to do this is I could put average or poor and then have Chicago listed only once. That will also work. Run, same results. Okay, save that one. Query 9, okay, close it out. All right, moving along. Show all of the employees that are managers and have received a performance rating, meaning that the field is not empty. Well, that's interesting. Let's take a look at employee. Yep, sure enough, some of the fields here are empty. All right, so we only want people who actually have a performance rating, so we want to exclude those guys or girls. Show the last name, salary, performance rating, location, position, title. Looks like we need all three tables. Okay. Query design, location, employee, position. Okay. Show last name, salary, performance rating, location, city, and position, title. Is that right? Yep. Okay. Show all the employees, they have to be managers and have received a performance rating. Let's start with the performance rating one, because that one's going to be a little new to you. So the criteria there is that it can't be empty. There's multiple ways to do this. So one way is to say not equal to that. So back less than greater than means not equal to. And then open close double quotes means not equal to blank or empty. There's nothing in there. So let's start with that and run it, and notice that we only get people whose performance is filled in. Whereas if we take that off, we'd still get those blanks. Well, let's double check and make sure. Run. Yep, there's some blanks. So that worked. Another way to do it is to say there's a couple of key words. Is not, null. Is not are reserved keywords in the SQL language, meaning it's not equal to. Null means empty. Access doesn't differentiate between null and blank, but other systems do. Null means there's never been anything entered into this field ever. Whereas it can be blank, meaning someone at one point entered something into the field, but then they deleted it. Access doesn't differentiate between those. Null simply means it's empty, and in this case we're saying anyone whose performance rating is not empty, and that will also work. Okay, so that takes care of that one. The other criteria is that are managers. Okay, well, let's take a look at position. We have manager, but we also have regional manager. Is a regional manager a manager? Well, let's assume that it is. Let's assume that they wanted both types of managers. So, using what you know already, you could still answer this, by saying is not null manager regional manager, and then copy this is not null again. And that would work, right? But let's say you didn't know, let's say there's 20 types of managers and you didn't know what they all were, and you didn't want to have to look them up, and you didn't want to have to make a record or a new criteria row for each one of those things. So this is where we can use what's called a wildcard. There's two types. One type of wildcard is a star. And the star, in front of that star, we have to use the keyword like. Okay? Like says now it's not going to be perfectly equal to this. It says take a look at the wildcard character and give us anything that ends in manager. And we don't care what's in front of it. It could be one character, it could be 200 characters. We don't care whatever's there as long as it ends in manager. And that will get us both managers and regional managers, because one of the things that could be in front of manager is absolutely nothing at all. So that'll get us both types. So let's view this. Now we've got both position types, regional manager and manager. But let's say some idiot accidentally spelled this as manager. Oops, I didn't want to do that. I got to do it from the original physical view. Let's go here to position and say that they spelled this one as manager on accident. Okay. Now when I run this, notice it didn't give me regional manager because it's not spelled regional manager anymore. Someone who was messing around accidentally called it manager. Let's say I suspect that someone messed it up. So what I'm going to have to do now in my query is say, I don't care what character they put here. So I put a question mark. The question mark, you put one of those for every character. It's also a wildcard, but it represents only one character, meaning it has to end in manage, then have any character they want right here in the second to last position, but then the last character has to be an R. So again, as many characters as we want here, but then we don't care what character is right there. Give us all of those people. Oh, there it is, and I see, yep, someone misspelled that, put an O there instead on accident. So I pull this up, and I'm able to fix it real quick. And then I'm good. Okay, so whenever you use either one of these wildcard characters, the star or the question mark, you've got to use a keyword like in front of it. All right, save that one. Let's close it. Yep, grade 10. Moving right along. All right. Show the last name, salary, position title, and location city of all the managers who earn less than $50,000 and work in Chicago or Miami. This is a perfect one that you should pause the video on and see if you can do it on your own now. Go ahead and try that. Okay, here we go. Create, query design. I need everything. Close. I want to show last name, salary, position title. Last name, salary, position title, and location city of all managers. So I'm going to need I've got position title. So let's take care of that. We know how to do all managers. We say like manager. Okay, who earn more than 50,000. Let's do that one. Whoops, I put it in the wrong spot. Like manager should go over here. Who earn more than 50,000, not a problem. More than 50,000. And work in Chicago or Miami. I take this to mean whether they're in Chicago or Miami, they still have to be some type of manager and make more than 50,000. So to handle that, to make it as simple as possible, I'm going to put Chicago or Miami. There we go. Okay, run it. There we go, more than 50,000. Now, this worries me a bit. Should we double check and make sure there aren't any regional managers who make more than 50,000 who also work in Chicago or Miami? So, position, regional manager is a 4. We know they're going to make more than 50,000 because the minimum salary for that position is 100. But do we have any 4s in Chicago or Miami? That's the question. So I'm looking for employees where location is 3 or 4 and position is 4. Okay? Location is 3. Nope, not 4. 4, not 4. 4, not 4. 3 and 4, not 4. 3. Okay, no, we're good. There are no regional managers living in Chicago or Miami who make more than 50,000, so we're good. All right, save this one. Query 11, moving on. 12, create a query that selects trainees who earn less than 19,000 or more than 22. Okay, show first, last name, city, salary, position, title. Looks like we need everything. Query design, location, employee, position. Close. We want first and last name. Then I saw location, city next. Salary and position title. Salary, position, title. Okay. Criteria is trainees. I think there's only one type of trainee, but let's check. Yep. Okay, so we're going to say position title is trainee. Okay, who earn less than 19 or more than 22. Okay, salary. Here's what we're going to do. Less than 19,000 or greater than 22,000. Just like that. Less than 19 or greater than 22. Show. Looks right to me, but we don't show No, we do show all those, right? Yep, we do. Okay, that one's good. Save it. Close. All right, query 13. All right, we're done with the easy ones. Query 13, we're going to start learning how to create what's called calculated fields. Calculate the difference between their current salary and the maximum salary of each regional manager. Name it salary difference. Show last name salary, maximum salary, salary difference. Okay, what is the difference between current salary and maximum salary? Take a look here. Under employee, we have, here's the actual salary they're currently getting. Position says, for that position, here's the minimum they can make and the maximum they can make. So these are different things. Actual salary and the theoretical limits. So what we want to know is for every regional manager, what's the difference between the maximum and their salary? What is that telling us, essentially? Basically, it's telling us how much salary cap room we have for each regional manager before they can't make any more. Or maybe before we need to make a new position that's allowed to make more. All right, let's do that. Create, query design. I think, what do we need for this one? I don't think we need location, do we? Nope. Employee and position. All right, show last name. I think it is then salary and maximum salary. Salary, maximum salary from over here in position. And then it wants this new calculated field, salary difference. Okay, here's how we do that. Right here, we're going to write the name, salary difference, for the new calculated field, and then a colon. Not a semicolon, but a colon. I can drag this out and move it. Now we're going to write the calculation right here into it. Now, if we want to, we can see a list of field names that are available. We don't need that. We know the name. I'm going to write salary minus maxim. Oh, I've got it backwards. Sorry. It's actually maximum salary minus salary. Now, here's the deal. It looks at this and it says we see the word maximum space salary. Are those supposed to be two different fields? We don't see a field called maximum. In fact, if as soon as I move, it says the expression you entered contains invalid syntax. What it's saying basically is we don't see a field called maximum, and we don't see like a minus sign between the field maximum and salary. What we need to do is use these brackets right here that says the keywords maximum and salary are part of an entire field name. Because salary is one word and there's no spaces, we don't need to put it around that. So I move off of there and it says, okay, now I got it. A new field called salary difference, but it's going to be the calculation shown right here. And these calculations can get as complicated as you possibly want. So what table is it from? We don't need to even put this in because it knows what tables those fields are from. It's not from one table, it's from a couple of different tables, so we just leave it alone. We come over here and we hit run, and here's our new field, salary difference. We see here's the max, oh, we forgot something. I just noticed. Of each regional manager. So we need position title after all. Oh, yeah, we have position, never mind. So let's put this in. It doesn't tell us to show the position though, so let's deselect it and add regional manager. There we go. So now it's only for regional managers. Run. We only have 2 of them. Rodriguez has $100,000 of room between the max and his current salary, or her, whatever that is. Oh, we don't know. And then 75 there. That's it. Okay. All right, I reordered things a little bit. I wanted to do this one next. So now our new number 14 here. Create a summary query to display the average and minimum salary of all job positions. Display job position, average salary, and minimum salary. Okay, so let me explain here. This is not the minimum salary, the conceptual minimum salary. This is the actual minimum salary, meaning, if we come back here to employee, here we talked about this before, there's this theoretical minimum salary for each position, right? They can't be an account representative and make less than $25,000. That's not what it's looking for. What it's looking for is it wants you to go through and look at all account representatives and find who has the actual salary that is the lowest of all people for that position. So this is a bit more complicated, but it's really not bad at all. Go ahead and make a query here in Design View. I think we need employee, position. Do we need location? No, it doesn't look like it. Okay. So, but what we do need though is to display job position, not a problem. Position title, average salary, and the minimum salary. So we're going to use what's called functions, just like you would in Excel, like the average function and the min function in Excel. We're going to use those to look at the data and return the average and minimum salary. So the way we do that is by turning on what's called the totals row, or the totals, I don't know, the button, how about? And let's put salary in there twice. Whoops, not 3 times. Okay. So notice when I turn on total off and on, see how it adds that row down here, and by default it gives us this group by thing. We'll just click on that down arrow and see here's all the functions that we can use. Actually, there's a whole lot more than this that we can use, but it shows us just the most common ones. So on salary, let's start with the easy part. We want to show the average salary and the minimum salary. So again, it's not this minimum salary, it's looking at the actual salary and finding out which one is the lowest, but we want to group it by position. So if we were to just remove position title here and run this query as it is, it says, okay, average of all employees is 65,280. The lowest of all employees is 18,500. Well, cool, that's great, but we actually want to know that broken out by job position, because it says average and minimum of all job positions. So the way we do that is we include position title, and I'll move it back to the front here. Oops. There we go, move it back to the front. And I leave this keyword group by. Group by says take all values of position title for all employees. So it's really important that we include this employee field, because it's going to say join employee with position title and collapse everyone with the same position title into one row. So the result should be what? Well, we should have as many rows as there are unique position titles, which is 4. And then it should show us from the employee table what the average and minimum is. So run that, and that's exactly what we get here. So it's collapsed all account representatives together and given us their average, and it even called it here average of salary. And then it's looked at all of the account representatives and found which one has the lowest salary and returned it right there. So something that's kind of cool that we can do, let's go back here to Design View. We had to use this group by because that collapsed things down. If we include anything else, for example, should we do it by performance? Let's see how that looks. All right, let's move performance over here. Notice performance also gets a group by. It's going to further break it out first by title, then by performance, and then give us an average and a minimum of salary. So let's run that one. All right, now this is interesting. So for account representatives, those who have an average performance rating, looks like their average salary is higher than those who are poor and less than those who are good. Well, that makes sense. Now these are those who haven't been evaluated yet. They seem to be doing really well. Looks like there's only one person, probably an outlier there. Managers, let's see here. Average makes sense. It's lower than good but above poor. Regional managers, there's only a couple and they've both had good, so that doesn't help. But trainees, good, higher than average, average higher than poor. All makes sense. So yeah, you can just keep breaking things out as you add more and more criteria to the group by clause. All right, but for the sake of answering the question, let's save that one right there, close it. All right, let's move on. Oops, scroll down here. All right, that's our summary query using the totals button. Now let's do a crosstab query. These are also very useful and interesting. In fact, if you've ever done a pivot table in Excel, they're a lot like a pivot table, but you can write SQL to create them. Anyway, let me show you what we mean here. Create a crosstab query to display the average salary of all location cities by position title. So this part right here sounds an awful lot like a summary query. just go by location city, break it out by city, and show us what the average salary is by city. But we actually want to make a matrix. Instead of breaking it out horizontally like I did, where I broke it out first by position title and then by performance rating, and both the criterias were down the rows, what I want to do in a crosstab query is have one criteria, location city, down the rows, and then the other criteria, position title, across the columns, across the top. So it's just the same thing, doing it a different way, making it into like a matrix. So sort by city, then by title. Let's do that. Create query design. I think we need all of them. Close. We want location city, position title, and average salary. Okay, location city, position title, and then average salary. So instead of turning on totals, I'm going to turn on crosstab. And then it gives me this, it also gives me total. And it knows location city and position title are text-based fields. It knows I probably want to group by those. Well, it looks like it did that by default on everything. Then salary, I want to average, right? Crosstab now, I have to have a minimum of 3 things in a crosstab query. It needs to know like what the x-axis is, the y-axis, and then what values that we want summed up in the middle. So the y-axis is like the row heading. Let's put location cities down the rows. The x-axis is the column heading. We'll put position title across the columns. And then in the center, the value we want is this that goes in the middle in the matrix, is the average salary. So always 3 elements to a crosstab query: row heading, column heading, and the value that goes in the middle. But notice I could actually, well, first of all, let me slow down one thing at a time. Let's run this one. So we see location city here down the rows, and now what we see across here are the position titles and the average at each intersection. The ones that are empty, what does that mean? It just means that there are no regional managers in Chicago. There are no trainees in Salt Lake City. Now I can't have more than one value if I want to. I can add salary again, and this time give me the, I don't know, the standard deviation for the fun of it, I guess. And then mark this one as also a value. And then it'll, it'll only allow me to do, there are 1 or more row headings. That's what it'll let me do. So I wouldn't want value. I could add another row heading though, and add, let's do performance as another row heading. Okay, so I can't have multiple, looks like all I can do is add their performance down here and then group by those. Oh, anyway, marginally interesting. I'm going to take this one off and leave it just like we had it. Okay, we're almost done. Save this one, query 15, awesome. There's just a couple more things I want you to learn, and that's how to work with dates. Really, one more thing. So dates are very useful. Let's start by listing all employees who were hired after January 1st of the year 2000. All right, it's not so hard. Create, query design, employee, close. It just says list, first and last name. There it was. First and last name. Hire date, not supposed to show hire date though, but criteria. All I want to show you is that with dates, you can also use operators like greater than. And then around dates, it's not quite a number, not quite text. We don't put double quotes like text, but it does need a marker. We use whatever you want to call them, hashtags, pound signs, whatever you want to call it. And we will put the date in here like this. So this means after 1/1/2000. Is that what it says here? After 1/1/2000. You might want to ask your manager if this is what they gave you, or for example on your, if you have an exam, for clarification. Do you mean we should include January 1st of 2000 or not include it? If we don't include it, then we're good. Run this. Let's go ahead and show, let's go back. Let's go ahead and show the date just so we can verify it's working. All right. What if we have someone hired on 1/1/2000 though? Let's make one of those employees 1/1/2000. Right here. Emily Mannon. 1/1/2000. So, close that. Should include her now. Oh no, it shouldn't include her because this says everything after that date. If we want to include that date, we can say greater than or equal to by putting it just like that. It's always the greater than or less than first and equal to second. Now we run it. Now Emily Mannon shows up right here. Okay, what's another way of doing this without having to include the equal to? Well, I could just say 12/31/1999, right? Because anything after that, it would include Emily Mannon again. So either one of those is fine. All right, let's close that one out and do the very last one. That's query 16. Finally, what percent of employees hired between and including these dates have an average or good performance rating? And it looks like we're going to let you cheat and perform the percentage calculation by hand after selecting the employees. All right, fine. All right, so this is just a chance to see if you can select people in between two dates and have average or good performance. All right, create, query design, employee, close. Does it say what to show? No, we just want to know the percent, so we really don't care. Let's just go ahead and put a couple things in there, last name, first name. Hire date and performance. Performance is average or good. Hire date, okay, let's do a between here. So after and including 1/1/1995, so let's do that one. So it's going to be greater than 1/1/1995. Don't forget your hashtags. And less than, what is it? 5/9/2005. 5/9/2005. Okay, there we go. So if it meets this criteria and that criteria, then that means it's in between those two dates. So run that. Ooh, I changed Emily. So I don't know if it's supposed to include her or not. So it's just whatever this number of people is divided by the total number of people, and that's your answer. Okay, that's it for queries. Queries in Design View. Let's save this and close it. This has been a lot at once. It's really important that you practice these things. So here's what I would do next. Now that I've walked through all of it with you and you've done it all at once, wait a day. Give yourself 24 hours. Don't watch this video, or at least have it on and paused, and see if you can come back to My Educator and do each of these things on your own without watching me at all. If you have to, turn on the video. But if you can do all of them without watching me, I'd say you're in a pretty good place for any exams or projects you have coming up. Good luck.